Um, Theorem 14.3 is going to help us to see how we can use the function's equation to be able to determine what the in-behavior statements are, rather than having to use the graph to figure out what the in-behavior statements are. We are going to find the in-behavior statements so that way we can eventually graph. That's going to be our end goal here. So example 14.9 is going to give us a chance to be able to practice that. And so I want to look at the instruction there and then use Theorem 14.3 at the same time. It says here, let f be a map from R to R. So this tells us that the domain of each one of our functions is going to be all real numbers. And then it says to describe the in behavior of each function. So the in behavior is going to be the description of those two arrows that are going to be going off of the window from your curve. There's only two statements. There is y approaches something as x approaches infinity. That's going to be for the right hand side. And then there will be y approaches something as x approaches negative infinity. That'll be for the left hand side. So each one of these equations that we have here will have the same general structure for the in behavior statements. But since we don't have the graph, we're going to have to use Theorem 14.3 to help us figure out what the behavior actually is for the y's. So it says that the leading term of a polynomial function's equation will indicate the in behavior. So all we have to do is be able to identify the leading term, and then the rest of the theorem is going to tell us what to do with that. Your leading term, as a reminder, is going to look like this: an times x to the n. So your an represents your leading coefficient, and n, which is the power on the x, we use that to represent the degree of our polynomial. So take a look at statement number 1. It says if an, now remember an is your leading coefficient, so if the leading coefficient is greater than 1, then your y value is going to approach infinity as x approaches infinity. Okay? But if your leading coefficient is less than 0, then your y value is going to approach negative infinity as x approaches infinity. Now, your leading coefficient cannot be greater than 0 and less than 0 at the same time. It will fit into one of those two categories. So notice that each one of these statements has x approaching infinity. That means that these are both going to help you with your right-hand side. You can use RHS to represent right-hand side. So the right-hand side, let's talk about part A here. So for part A, we have f of x equals 5x to the third plus 7x squared minus x plus 9. 5x to the third would certainly be the leading term, and 5 would represent the leading coefficient. 5 would be larger than 0. It's positive. So that means that the y value is going to be approaching positive infinity as x approaches infinity. That's what statement number 1 helps us with. Statement number 2 is going to be for the left-hand side, which is represented by x approaching negative infinity. Now again, you're not going to use both of these from the theorem. You're only going to get one. So the test here is if n is even, then we have something. If n is odd, then we have a different result. Remember, n represents the degree of your polynomial. So the degree of your polynomial cannot be both even and odd at the same time. It's either even or it is odd. So if the degree of your polynomial is even, then that means that y is going to approach the exact same thing as number 1. statement number 1. If your degree is odd, then y is going to approach the opposite of statement number 1. So going back to part A. In part A, we have that y is approaching infinity for the right-hand side, for statement number 1. And we also have that the power, or the degree, is going to be odd. So since the degree is odd, that means that for our second statement, we need y to approach the opposite of what it does in the first statement. So that means y is going to have to approach negative infinity. And that gives us the two end behavior statements for part A. Let's do the same thing for part B. In part B, we will identify the leading term as negative 5x to the 4th, and the leading coefficient is negative 5. So since the leading coefficient is negative, the y value has to approach negative infinity for the right-hand side. So the leading coefficient is always going to help you with describing the right-hand side in behavior. The degree is always going to help you to describe the left-hand side in behavior. Now, the left-hand side in behavior is either going to look just like the right-hand side, or it's going to be the exact opposite. Since we have an even degree, that means the left-hand side should be identical to the right-hand side. So y is going to approach negative infinity just like it does for the right-hand side statement. And this gives us the end behavior for part B.